Hello, my name is Mary Rose and I'm the Floor Pulse Plant Scientist, and today I want to teach you how you can test sensors in lab when you recover them from the field. So reuse is an experimental technique that we're working through, but you can bring the sensors back to the lab, clean them, and test them to make sure that they're responsive before you go through the hassle of reinstalling them.
Okay, so for this test, you'll need a data logger that connects to a real-time readout, like this one here. It's refreshing. I have my sensor here in water, and it's been in water overnight, and I've cleaned it off as much as possible. I also have a fan going, and that'll help the sensor dry out. I'm wearing gloves to prevent contamination, and I have napkins to dry out the sensor. So this test will look like I have my sensor relaxing in water, fully hydrated, making sure that it's measuring stable, and I'm going to take it out and dab it dry and let it dry out about 10 bars or so, and then place it back in water and record the times that it takes to both dry out and recover and rehydrate. And that will tell me whether or not it's responsive enough to use. So let me show you what that would look like. All right, so we have this probe that we've recovered from the field, and it's been sitting in water for overnight to clean the cowlin, and then been relaxing in water for a while. So on the readout, we see with the scale on this side that it's relatively flat. It's not fluctuating very much from 3.06 millivolts. And that's what we would call the offset. So that's the measured voltage in water, and probes will read 0 bars at offset. So before I begin with the dry out test, I'm going to make a note of the probe name just to keep track. This is B983. It's on the label here. And then the offset voltage I'm going to record is 3.06 millivolts. So once again, I'm going to take the sensor out of water and let it climb and dry out. So the fan is on here, and let's take this out of water. I'm taking it out at 32:15, making note of the time that I take it out at. And we're going to wait for it to climb to around 5 millivolts. So that's a 2 millivolt difference. And this sensor is responding pretty quickly, so we know that it's drying out okay. I'm gonna dab it dry just to make sure. But as we can see in the readout, it's shooting up, so it should be drying out properly. And we'll wait for it to reach a little over 5 millivolts. It's important to watch the readout really carefully when you're doing this, because the sensors can cavitate if they dry out too much. So I'll show you what that looks like, but we want to be paying attention. Okay, we're going to put it back in water at 33:45. And now we're going to wait for it to fall 1 millivolt. Okay, so it took about a little under 7 minutes for it to fall back down to 4.06 millivolts. So I'm going to mark it as 40 minutes, 30 seconds. And so this probe would be an example of a pass, because it took less than 3 minutes to climb 2 millivolts and less than 30 minutes to fall 1 millivolt during recovery. So now I'm going to show you some examples of probes that wouldn't be a pass. Okay, so
So one common issue that we see with probes that are recovered from the field is that they could have substances either from the tree, from the install, blocking the sensor phase and making them less responsive. So this is what we would call a slow or non-response probe, where it has difficulty drying out within the time that we want to see it doing so. So I'm going to go ahead and dry out the sensor the same way that I have been doing with all the other ones. This sensor is E982, and I'm going to take it out of water at 1710 and wait for it to climb 2 millivolts, and we will see how long it takes to do that. So we want to see it climb to 2.35. Okay, so this sensor finally reached its end voltage at 2435. So that's a way longer than the 3 minutes that we would like it to climb that much. So this sensor would be marked as slow. Likewise, if it now takes over 30 minutes for it to rehydrate back down 1 millivolt, we would also call that slow. So these sensors aren't broken completely. There is a method that you can use to recover them, and I'll show you what that looks like. But let's just wait for it to recover back down, just to see how long it takes. Alright, so it reached that time at 27:05. Okay, so with this next sensor, I'm going to just show you what it looks like for a sensor to cavitate in the readout. So I have probe B981 with me right now, and the offset is measuring at 1.28 millivolts, staying pretty constant. And just like with the other probe, I'm going to dry it out. Wear my gloves, have the napkin, fan is on, and we're going to dab it dry. We'll just say, for example's sake, that I got distracted and I'm not watching the output. So ideally, I would put it back in the water as soon as it reaches 3.28 millivolts. But I'm just going to wait for it to dry out completely. We go. See the sharp drop back to offset indicates that the sensor has dried out and cavitated, so it can no longer be used. So even when we put it back in the water, it won't be able to rehydrate. So that's what that would look like. Okay, so a common thing that we see when reusing probes is that sometimes if they aren't handled carefully during the removal process, they can come back damaged. And this would be an example readout of what that might look like. So if electronics are damaged, you can get fan readings, you can get super high voltages that don't make sense when the channel is empty. It reads 30 volts. And a sensor should be well below that. So here, this one is reading 201
millivolts, and it's quite jumpy. It also has a few breaks in the readings because it's not making a proper connection with the data logger. Some other things to look out for with electronics are large spikes and jumps of larger than 3 millivolts. This would be an example of an unstable output, and it wouldn't be a reliable offset measurement, even under recovery. Then if we take the sensor out of water and try to dry it off, we notice that it spikes around and it is not responding consistently. So it's going up and down, reading the ANSAT points. So this would be a damaged and unusable sensor. Okay, so the last sensor type that I want to show is a no response. So a variety of things can cause a no response sensor. Either pores or tube blocks for it to respond, or there's some damage, or it's cavitated. So they're important to identify and troubleshoot with. So I have this probe C100 that's reading at minus 3.57 millivolts. And if I take it out of water, like I have done with all the other probes, at 3420, fan is going, taking my napkin and dabbing the sensor face dry. We see that it is not drying out. So even when I triple check with my napkin, force it in front of the fan, it is not moving. The voltage is staying the same. So with this output, we want to wait at least 2 minutes to make sure that it gets a chance to dry out. But if it doesn't change after 2 minutes, then we know for sure that it's a no response, and that it would be unusable. That's been a few minutes. I've dabbed it dry a couple times and it's not moving, so I can call this a non-response. All right, so I mentioned earlier, if your sensor is slow, that you can refurbish it slightly. The reason why SLAM sensors are slow is because the sensor face right here will be contaminated with anything from the plant, stuff like that. So what we can do is take a little sanding stick and lightly rub some of that contamination off. So I'm gonna go ahead and wet the sanding stick.
and the probe is in water. And rather than dabbing the probe dry with paper towels, we're going to keep things as wet as possible because it'll help prevent the probe from cavitating in dry air. So I'm going to pull it out. We have the clean sanding stick, and I'm going to lightly scratch the top of the sensor face for about 60 seconds. Just going back and forth. And you only want to touch the very top of the sensor because that's where the pores are. And that's where contact is being made with the tree. So just very lightly going back and forth. Want to be careful that you're only touching the top of the sensor. And applying light pressure because excessive sanding can break it all together. All right. So after about a minute, 60 seconds, we can place the probe back into water and swish it around a little bit to remove the debris. Careful not to bang it on the sides of the cup. And now we can let it relax back in water and retest it with the dry out test just like we did before.